So I think I'm audible to you. Okay, very good evening to one and all. Thank you for your presence. So very good evening to Bharatraj Singh, Suja, Sri Satya, Vaishnavi, Sampath. Very good evening. Thank you for your early presence in our 30-day masterclass. I think I'm audible to you. If my voice is clear, just put yes in chat box. Just a minute. Okay, Muhammad Tawfiq, hi sir, hi. So very good evening to good on all. Today we are going to see a system like constraints. So it is very important topic. So good evening. So thank you for your presence. So let's wait for a few minutes. So and then if my voice is clear for you means just put yes in chat box. If my voice is clear for you means just put yes in chat box. I'm audible to you. So just put yes in chat box, then only I can move further. Vaishnavi P, very good evening. So constraints, yes. Thank you your response, Lamba, Manmeet Lamba. So let's wait for a few minutes. At least some people have to join. Then only we can start. So let's wait for a few minutes. We will start at sharp 7:05. Okay. So thank you for your responses. So constraints is very important topic in SystemVerilog. So why? Because of we are doing randomization for whole packet of classes. Okay. So it is very important. So I will show you there are a lot of constraints in the SystemVerilog. Like there are a lot of types of constraints. So it is very important. So it is mostly, so while if you want to write the constraint means you have to logically good, then only you can make more write more constraint for your logic. So why we need constraint means, so we are doing randomization. To limit the randomization we can use the constraint. So Sri Krishnan, very good evening. So let's wait for a few more minutes to so today we are going to see SystemVerilog constraints. So I will start with definition and then we will see the types and then we will see some we will try to write the code for constraint examples. Okay, I think I can start now. So before going to that I will show you the constraints look like. So SystemVerilog constraint. So now first of all we will see the what is constraint. So constraints is nothing but to limit the randomization we can use the constraints. So why we have to limit the randomization means, so if you are using some signals you are doing randomization. So for example assume like a signal AIC1 signal, it having the data type of integer data type. So if you randomize the integer data type means you will get the n number of values. So for example you need only values between the 10 to 100, but if you randomize the integer data type of signal it will give more than 100 or it will give minus values, it will give the positive values. So if you want only positive values means you can use the constraint to get the positive values for particular signal. So on that scenarios the constraints are more useful to verify the particular values, to verify the particular range of values. Okay, so constraints control randomization by specifying the condition that random variable must satisfy. So first thing is define valid range for random variables, and then specify the relationship between the variables, and then control probability distribution, and then generate meaningful test scenarios. So while writing the test bench, while writing the test scenarios, the constraints are mostly used. Why? Because of, example, if you take like a UART protocol, you are writing the test bench for your protocol. The main logic of your protocol is the start bit must be low, and then each and every packet of data we have to add the start bit. Firstly, initially we have to send the start bit to receiver, then only the receiver will understand that it is a UART packet. First bit is start bit and the last bit is stop bit. So if you say like so in between, the transmitter will send the 10 bit of data. Okay, 10 bit data. First bit is start bit, and then 8 data bits, and then finally last bit is stop bit. So first bit is start bit means 0. Okay, 0 means, so we can write some condition, we can write some logic in constraint. So each and every packet of data sending from TX to RX in UART, first bit must be 0. So we can set like logic this also. So we can set like a first bit must be 0. This setting of logic for particular transmission of signal, by using SystemVerilog constraint, we can achieve that. So this kind of logic we can set by using the constraints. Okay, and also we can assign by using the assertion also. Assertion also are helpful for verification, to making the conditions, and also we can verify that. So if you randomize one particular signal means, we can verify that whether this signal is covered or not. For that reason, we have to use coverages, SystemVerilog coverages. We will see upcoming classes. The main thing is constraint. So we will do randomization. So for particular signals, the value must be you only require specific values. For example, assume like a integer data type of signal B. So B is one signal. That particular B signal must having the value of 5 always. Okay, means the B signal must have to have a value of 5 only. So while doing a simulation, that particular B signal must have 5 all the simulation time. So from starting to ending of simulation, the B signal must have to have a value of 5, means you can write the constraint for that. Okay, so by using that constraint, the value of B, signal value of B is always 5. So we can set like this condition also. By using this condition, we can limit the range. We can limit the randomization. We can set the range between the starting and ending, between start and end bit of ending of randomization, and also we can give the probability of randomization. Probability of means, so from particular values like from 10 to 5 or 5 to 10, this kind of we can set the probabilities. This kind of values will do more, it will do repetition in simulation. While doing randomization, it will do repetition. So we can limit the randomization, we can set the logic, and then we can give the probability of randomization for particular signals. So this kind of benefits we having in the SystemVerilog constraints. So we'll see one by one. Okay, so and then so why we need constraint? So we valid to write the valid test scenarios, and then probability control, and then real world modeling, and then efficient coverage. So and then this is a basic syntax of constraint. So you can see here, this is one class, these are my signals inside my class, length and data. So this is int data. This is refers to dynamic array. Okay, this is a dynamic array syntax. Okay, so and then this is my constraint syntax. Constraint name, inside the flower bracket we can write the limitations. So I will just write one reference, I will just write one code for your clarification. There are a lot of constraints in our SystemVerilog, a lot of types. Okay, a lot of types of constraints. So firstly I will create one class name is A, and then end class, So and then I will create the signals. So by using the rand keyword we can do randomization of particular signal. If without rand signal you can't do randomization. But if you want to do randomization means you have to put rand keyword in front of the data type of your signal. So rand integer data, this is my signal, I insert my class only one signal with the rand keyword. So with rand keyword means you can do randomization for this signal. Okay, so and then module tb, there is my module name n module. So here I'm doing the I'm making the instance name. So I mean object name for my class. A1 is my object name. So and then initial begin. So I'm creating the simulation time. Here I'm allocating the memory for my handle. Okay, so and then here I'm by using the handle name I am randomizing the class A. So you can see here the syntax. So this is my A1 is my handle name of my class. Okay, handle name for my class by using the randomize method. This is my randomize. So this is a one randomize method. So it will do randomization of this whole class. So inside that class I am declare the signals by using the rand keyword. So by using the rand keyword we can randomize the class. I can randomize the whole class. So a dot is refers to handle name of my class. Randomize is one method, it will do randomization. Okay, so I didn't so and then I will print my value. So print my a value, so data value. So data I want to see in my decimal. So data. So just a minute. So I will choose my simulator Costa Sim. So here you can see here there is my class. Inside my class I have one signal. The signal name is data, and then data type is integer data type, and then int data type, and then I'm declared as a rand. So rand is one keyword. It is used for randomization. Without rand keyword for particular signals you can't randomization. And then I'm creating the handle name. So this is my handle of my class A1. Then by using I'm allocating the memory for my class, and then I am doing randomization. So how we can do randomization means by using the handle name you can do randomization, and then I'm displaying the randomized value by using the display. Okay, and then I'll save and run. So here I have to give like a1 dot. Okay, I'm accessing the class properties. So by using the handle name only you can access the class property. Okay, so you can see here the data value is -70395011. So I am doing randomization, but I got value of minus by using I'm getting the value of minus sign. So -7039 kind of thing. So while doing randomization I will get either positive value and then negative value based on your data type. Okay, so if you want to limit this randomization, why? Because of I'm getting the unknown unexpected value. So I won't need this minus value for my test scenario. So I only need a positive values from 0 to 50. So from 0 to 50 means I can limit I want to limit the randomization. It will start from 0, then it will end from 50. So inside the in between the 0 to 50 only I want to get the values. So for that you can use constraints. So how you can write the constraint means, inside the class you can write the constraint. The basic syntax is, so constraint name is C1. So and then this is a syntax of the constraint. So the main thing is the main difference is, so we can use a semicolon to end the line, but in the constraint we have to give the semicolon inside the flower bracket. We have to give the semicolon inside the flower bracket. Okay, so this is a constraint name. This is a constraint name. So inside that you can give the limitation, or you can give the range. So I will give the data must be less than or equal to 0, and then this is my first logic. Okay, and then data greater than or equal to 50. Okay, so this is my first logic. Data must be, so I am assigning data, the data is my signal name. Data less than or equal to, it means it will start from 0, and then data greater than or equal to 50. Sorry, greater than or greater than here less than. Okay, data must be greater than 0, greater than or equal to 0, and then it will end from 50, and then 50 are in less than 50. So this is my logic. So this is my limitation of randomization. If I run means I will get the values between 0 and 50. 0 and 50 only, 0 and 50 only I will get the values. So this is how we can give the limitation of randomization. So if I run this means I will get the values between 0 and 50. So this is a basic example of constraint. Okay, so you can see here I am getting the value of randomized value of 30. You can see here 30. So how I am getting the 30. Previously I got some random values with minus sign, but here I am getting the expected value of in between the 0 and 50, 30. So by using this constraint we can achieve this. So and also we can write a number of types. So there are a lot of types in the constraint. This is a basic type of constraint. So you can limit the range, you can give the range of randomization, you can give the range for randomization. Okay, so and then I will move into another types of constraints. Okay, this is a basic definition of constraint, basic example for constraint writing. Okay, so keyword, this is a constraint, is a keyword, constraint name. Inside the flower bracket we can give the ranges. This is a basic constraint syntax. So and then there are a lot of constraints, so we will see one by one. Okay, so you can see here, this is the inside. By using the inside one keyword, you can see here constraint name here. So inside that I am giving the range between the 16 down to 1518. This is my range. So but here the length is, you can see here length is signal name. So inside is a keyword. So it means inside is a keyword. It is defining that inside my particular signal I want to randomize between the range of 0 to 50 or 64 to 1518. So I am giving the range for particular signal. By using this inside keyword you can give the range by using inside keyword, or else you can also use this kind of less than or equal to operator, but it will take one or more line. But by using this inside keyword you can give the single line limitation. Okay, so and then so and then this is my inline constraint. This is named as named constraint. So and then inline constraint is nothing but, here you can see here I am doing randomization. P is my class name. This is my randomization method keyword, and then by using with keyword we can write the inline constraint. So constraints are only right inside my class. Inside the class only we can write the constraint, and but the inline constraint is only one constraint we can write inside our initial begin. Okay, so I will show you that. So before going to that, I will just inform my internship program. So if you guys are really interested in this masterclass, you can convert into this masterclass in 1 month of internship program. internship on advanced VLSI design and verification. So by using so these are the benefits you will get at the end of 1 month of internship. Like you will get the all 30 days recorded session, PPTs, source code. You can also download that. So and then you will get the 4+ executive exclusive projects. So and then you will get the IETE confirmation letter. So and then you will get the 180 days LMS course access. It is literally 6 months of access. So and then you will get the assignment task weekly. We will give weekly. So and then you will get the academic internship report. So if you are a college student means it is very helpful for you. So and then you will get the 1 month of certificate from IETE. Okay. So and then these are benefits. You will get a discounted fee of just 999. So this is a discounted fee of just 999. Our regular fee is 499. So by using this registration link you can get the internship program. So and then after clicking this link you will see this window. Okay, in the screen you have to choose this one, like advanced VLSI design verification, then only you will get the internship program. So and then this is a sample certificate you will get at end of 1 month of internship program. Okay, so these all things you will get, and this you will get at a discounted fee of just 999. So our regular fee is 499. So this is a limited time period offer, so just avail it if you guys are really interested. So you can use this link. You can also get the link in chat box. Okay, so and then we will move into next constraint. Okay, so and then let's see the example of inside and with inline constraint. So I will write some here also I can write. So this is my constraint 1. So I can write n number of constraint. Okay, I'm going to write constraint 2, constraint C2. So here, so I'm going to use inside constraint. Okay, data is my signal, inside my keyword of constraint. So that syntax is inside the square bracket. I can give the range. So how I can give the range means, so I just comment these lines. I just comment this line. So on that particular range I am giving here 0 down to 50. It means it will start from 0 and then it will 50. So in between the 0 and 50 only I can do randomization. Okay, so this is a syntax. So this is syntax what we have seen. Okay, if this is an example for inside constraint. Okay, the main thing is flower bracket, sorry, here flower bracket, square bracket, and then close square bracket, and then flower bracket. So this is a syntax. Constraint name, this is my signal name, this is my inside keyword, this is my limitation, this is my range 0 to 50. So I'm giving inside my square bracket, and then that range are inside my flower bracket. Okay, and then this semicolon is refers to closing of constraint, one constraint logic. So okay, and then I save and run. So here I'm also getting 30, same value. So and then I'm going to use repeat block. So repeat I'm going to repeat up to 20 times or 20 times. Begin and then here end. So this is my repetition block. I'm going to randomize off up to 20 times, and then each time of my randomization I am displaying my value. So this is a definition of this randomization, this repetition block. So this block will it will do repeat of 20 times, and then each and every repetition I am doing randomization, and then I am displaying my value, output value. Okay, so and then I run this. So you can see here I am getting the repetition of 20 values. There are, you can see here, firstly I am getting 30, 22, 31, 27, 19, 15, 46. You can just notice that. So I am getting the values in between the 0 and 50. No, not more than 50, not less than 0. I am getting the values between the 0 and 50. So this is how we can use the constraint for particular logic. So for particular signals only needed for between needed specific value means we can write the test cases by using this constraint. Okay, so you can see here 36, 27, and also you can see the repetition. Here also I'm getting the 36, and also here also I'm getting the 36. So 36, it means just a minute. So here 36 it is repeating, so it means I am getting the 236 value for in my randomization. So to neglect that, you can use RANC keyword. So RANC means it won't do repetition, so it will do repetition after completing the cycle of all combinations. Okay, after that only it will do repetition till after without that it won't repeat the values. So before I am getting the repetition values in the randomization, but here I didn't get any repetition value. You can see here you can't see any repetition value. Okay, 31, 43, 42, 26, 16, 32, 34, 25, 3, 30, 50. There are that results, that randomized outputs are specific only. There is no repetition. So how you can achieve that means by using this, just a minute. So by using the RANC keyword, so before I am using only RAN keyword, so by using that RAN keyword means if you do randomization means you will get the repetition values, but if you are using RANC keyword means you won't get the repetition values. Okay, so this is a basic syntax. The main thing is constraint name, this is my signal name, this is my inside keyword. So this is my range of giving randomization. So this is a range the randomization will do in between the 0 and 50. Okay, so and then save. So and then we will move into another constraint operator. So and then solve before going to that, I will just, it is simple only, implication operator. So implication is nothing but, so you can see here there is one constraint name. This is my signal. If my signal having high, so assume like a 1. If the mode having high means I'm giving like this size is a signal, so greater than or equal to 100. It means if the mode is high means that particular signal will getting the randomized value of more than 100. Okay, this is a logic. So by it's like if else condition. If a particular signal having high or low, if a true means, if this condition true means it will execute this implication operator, it will execute implication constraint. So this is a symbol for implication constraint. If this condition true, like a turn, it is work like a ternary operator. If this condition is true means it will allow to execute implication constraint logic. The logic is the size is a signal name, so more than less than or greater than or equal to 100. It means that particular signal size will get the randomized values of more than 100 or equal to 100. This is a logic. So same like if the mode, this is also one signal. So mode signal having the low value, it means 0 value means this that size signal must get the values between the values from less than or equal to 50. It means it will get the values less than 50. This is a logic. So I will use this logic in the same code. So you can from this also I can use. So I am creating another signal. Okay, here I am creating another signal, rand c, going to use logic keyword. My signal name is A. Okay, this is my A signal. So I am going to create another constraint. constraint. C3 is my constraint name. So okay. So and then I'm going to use signal like a signal. If having the high value, one value means I will just assigning. If a signal having the high value means I'm just assigning data. Okay, I'm just open and close bracket. Data equal to 5. Okay. If my signal A, this is my signal, second signal. If it is A having the high value, having means 1 means the data signal must having the value of 5. Okay, this is my logic. So this is a syntax of implication operator. This is a implication operator symbol. Okay. So and then I will just save and run. So I got error in the SystemVerilog 11th line. So I will just show you another example here. So you can use the insert keyword inside your data. So data inside 5. Okay. So this is my syntax. If my signal here having the high value means I will data that particular signal must having the will give the output only 5. So here I'm getting square bracket error. We'll change to flower bracket. Then I will check. So I'm getting the value of 18. So and then after this repetition block, I'm assigning the a1 dot a signal equal to 1. So after that I'm displaying my output of data. So display data equal to %d a1 dot data. Okay. So here I am just assigning the value a equal to 1 for checking this constraint 2. So if the a having 1 value means I will get the data output must be 5. Okay. So let's check that. But I'm only getting 8. Oh, I'm getting 8. So this is syntax for that. So I just remove this always block. So I'm assigning a value a equal to 1. If my signal a equal to 1, a signal having 1 means I will get the value only 5. but I'm getting 18. Just a minute, I will check and 0. So why? So sorry, I didn't randomized. So I think I just command this constraint, first constraint. I will do only line. I'll do only run the last constraint. So let's check the output whether I'm getting or not. So it won't work. So I'll just change. So if my equal to just data equal to 5. Okay, so I just run this. So here also I'm getting the minus value. I think that this constraint is not working correctly in this EDA playground. Or else I can use this method also. Data inside range between 4 to 6. Okay, this is a range. So let's check this. If I getting 5 or 4 or 6, if I getting this 4 5 6 means it's working correctly, but I'm getting the minus value. You can see here the minus value I'm getting. So I think there is an issue in the simulator. Sometimes it will do some randomize. It will do some mistakes. So I just comment this also. So I can give like a one bit of binary 1, and also here I'm assigning binary 1. Let's check this method. So I'm getting the correct. I'm not getting the correct value. I'm expecting the values between the 4 5 6, but I'm getting the 6 0. So I think I'm going to use Costa Sim. There is an issue in the EDA playground, so I will move into Costa Sim. So main thing is this is a basic thing of inside operator, like implication operator. If it is true means it will allow to execute this logic. After the implication operator, it will allow to execute this logic. Okay, so and then I will move into distribution constraints. So this is an example for the constraint syntax for the distribution constraint. The main thing is constraint name. This is a constraint logic. So and then this is my signal name, length is my signal name. So and then this is a keyword for this distribution constraint. Okay, this is a distribution constraint. So that main thing of distribution constraint means it will give the weightage or it will give the probabilities. It having the two types. One is a distribution weighted and then weighted distribution. So main thing is we can see here 64 down to 127. It means, so I'm assigning this is a symbol for 30. So symbol for the distribution operator. Okay, so colon equal, this is refers to distribution operator. So you can see here this percentage value. It means while doing the randomization, the 30% of randomized value you will get from this range, like a 16 down to 127. So and then 60% of value you will get from 18 1 to 8 and down to 511. So and then you will get the 10% of value from the 51 to 1024. So you can give the probability values. This is a control of probability. So by you can give the probability of getting a randomized value in between particular range. Okay, so 30% of values you will get from 64 to 127, and then 60% of value you will get from 128 to 511. You will get the 10% of value from 512 to 1024. Okay, so this is a thing. So same thing, and then this is a randomization probability. Data is also one signal, and then control is one signal, error is all one signal, and then I'm giving the percentage of probability. So data will getting the probability of 70% of randomization, and then control signal also you will get the 20% of randomization, and then error is a kind of signal, it will get the 10% of probability. Okay, so this is a operator explanation. So this symbol is refers to each value in a range gets a equal weightage. So and then this is another distribution operator symbol. It will get the total weight divided across the range. It means 5 down to 0. So 5 down to 7. It means 5, 6, 7. So there are 3, 5, 6, 7. It means 3 values. So it means it will divide by 3, 5 by 3, 6 by 3, 7 by 3. So it will divide by 3. So you will get some weightage. That way, that weightage will assign to each and every randomization. Okay, so this is a weighted distribution of constraint. So and then solve before. So solve before is nothing but we can set that. So you can say the logic solve before. So this is my constraint name, this is my signals, this is my constraint name, solve mode. So this is my one signal, so mode is one signal, and then so you can see here currently correct. So solve mode is one signal, before size. So before the size signal randomization, the mode signal will get the priority. So I'm giving priority for particular signal. So I'm comparing between the mode and size signal, the mode signal will get the priority while doing randomization. And also same here, mode will get the priority compared to priority signal. Okay, before the priority signal, the mode signal will executed, will randomized. So mode equal to 1 in size is one signal, inside you will get this range. So I will just copy this this code, and then I will try to run in my EDA playground. Okay, class okay, so this is my class. I have 3 signals. So priority underscore 1. Okay, here also I'm giving the same thing, priority underscore 1. So priority one keyword here, so don't use keyword as a signal name. So signal name is our mode size priority underscore 1. So this is my constraint name. So firstly I have to solve mode logic. This is my mode constraint. So this is one logic mode signal. So firstly I have to get the randomization of mode before the size, and also this is my solve before. So firstly I will get the mode randomization before the priority signal. Okay, so and then I'm going to write the module. So or else, and one more thing is, inside the module only, inside the module also you can create the class. Module name is TB. So inside the module I'm creating the class, and then I'm creating the memory for that. So transaction. So transaction, this is my class name, A1 is my handle name. So and then initial begin end. So A1 is my class name, so A1 dot, so I'm creating memory for that, I'm allocating memory for that. So and then in the repetition block repetition of 10 times. I'm doing randomization, so a1 dot randomize and then display my I'll display my outputs. So what I'm displaying means, so I'm giving size. So mostly I'm giving this mode logic only for size. So okay, so I will display my size output. Size, not only size, I'm giving mode. I want to display my mode signal output, mode in the decimal, and then I want to see my size output, size signal output in the form of decimal. So and then a1 dot mode and then a1 dot size. Okay, so and then end module. So inside the class also you can create the memory. Okay, and then save and run. So main thing is I'm doing the solve before constraint. See what it will do means, firstly it will do randomization of mode signal before the size, and then it will do first mode signal randomization before the priority. So from it means, so firstly the mode signal having the first priority for randomization. Okay, so near class syntax error. What is that error? In class randomization, everything's correct. So I think I will choose to custom tool. Why? Because of I'm getting error. So I will show you the another code. So you can see here, this is my another example class. So it will do findings. It will helpful. What I am giving writing means, just a minute. Okay, so you can see here, there is my new constraint I'm going to use in Costa Sim. Why? Because of I'm getting error in EDA playground. Sometimes, so why? Because of the constraint coverage assertion, or for if you're doing this kind of thing means you can use that tool, official tool like a Costa Sim. So in the online platform EDA playground, it will give some unknown values, unexpected outputs. You can use the tool better. So here you can see here inside my module, I'm creating the class. This is my class, and this is my signal A. So this is my constraint. I'm using inside keyword, and also I'm giving like another condition is a modulo of 2 equal to 1. It means it will print only the odd numbers in between the 30 to 60. So I will just show you that output. So first name is in the VLOG you have to give the file name. In the VSM you have to give the module name. So module name is odd, file name is cons underscore odd underscore dot sv, and then run and all. This is a command for Costa Sim. So inside the Costa Sim I will just do rundown to command. So it will do execute. Here a1 dot a. Okay, I'm displaying the a1. I'm displaying the a signal are inside my class. So by using the handle name only I can access that. So and then I just run again. So you can see here I'm getting the values in between only 30 to 60 odd numbers only. Okay, so I will just reduce my repetition time. I'm give only 5. I'm going to do randomization of 5 times only. Just a minute, I will run again. You can see here 35, 31, 55, 33. This is my output. You can see inside the corner, inside my left corner, 35, 31, 55, 33, 47. This is my output. So I am trying to write the same thing like inside my module. I am creating a class, but I got error inside my EDA playground. Why? Because of some online platform does not have that kind of compatibilities. That kind of facilities it don't have, but in the tool inside the Costa Sim I can run that same code. So I can run the same code means inside my module I am creating the class. So the tool having the facilities, but the online compiler don't have the facilities. That's why I'm getting the error. So while writing the constraint assertion coverages means you can use the official tool is better. Okay, so here main thing is I'm creating the class name is A, and then the signal name is small a, logic I'm using the logic keyword, and then this is my two constraint. Though this constraint, the main constraint, first constraint name is A1, it will do randomization in between the 30 and 60. Why? Because of I am using the insert keyword. This is a signal A. Okay, so and A is my signal. This is insert keyword. In bit I am getting the value between the 30 and 60, and then I am using the another constraint. The what constraint means? So I will just zoom it. You can see here constraint B1 a model of 2. It means I am doing model operation. So if it is if you are dividing some signal by 2 means you will get the remainder. If the remainder is 0 means that is even number. If the remainder is 1 means it is an odd number. So I am going to print only odd number in between the range of 30 and 60. Okay, so this is a logic. So if you want to print the even number means here you can give the 0. If the model of particular signal, model of 2 for the particular signal, it will, if the remainder is 0 means and that particular value is even number. So I am using this logic means I will get only even numbers. Okay, I just save this, then I will run in the Costa Sim. So I will get only even numbers. You can see here 38, 30, 34, 34, 54, 56. These are my even numbers. So how I'm getting the even number means this logic. This is a logic. So this is how you can expect the interview questions while attending the interview. Someone will ask, so write the constraint for getting the even numbers only. Write the constraint for getting the odd numbers only. Another time you have to use this kind of logics. Okay. And also I will show you another interview kind of question pattern. So this is a, you can see here, so this is a logic. So this is a logic you will get as a output, like this is a sequence, like a 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So this is a sequence you will get as a output. So this is my array, integer is a integer int a, this is my dynamic array. So I am going to randomize, I am going to give the constraint. After that I will get only output like this only, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. This kind of sequence you can get by using the constraint. By using your logic you can get. So this is a logic for that. Firstly, you can see here totally array size is 10. Totally 10 number of values. 10 number of values is there. So this is a dynamic array declaration. This is expected output. So totally 10 numbers. Total it means the array size is 10. So by this keyword array size, like a dot size, it means CA is a signal name. Dot size is a function, like a kind of keyword. So it means I am assigning the size of array. So size of array is 10. So and then for each loop. So at every array like a for at every array iteration, like it will start from 0 and then it will end from 10. Okay, 9, 0, 1, 2, 3, 4, 9. Why? Because of array size is 10, totally 10 large, totally 10 memory locations. So it will do for loop. It will do like a for each is a keyword, it will do like a for loop. It will start from 0, it will end from 9. So it will iterate one by one, 0, 1, 2, 3 kind of thing. So and then at I'm filling the values. So at the every time I model of 2, it means if my event location in my event location, I'm just assigning the 0 value. Why? Because of 1 is my even location, sorry, 0 is my even location, 1 is my odd location, 2 is my odd, 2 is my 0, 1, 2, 3. So this is the locations. Just a minute. I changed my pattern. Okay, so this is that. Okay, here is a signal, this is a range. Zero 1, 0 2, 0 3, 0 4, and then 0 5. Totally 10 memory locations. So this is a index. The index of this is index of that. So 0 is my first index, 0th index. 1 is my first index. 0 is my second index, third index, fourth, fifth, sixth, seventh, eighth, ninth, 9. Total 9 index. So in my even index, I am assigning 0. So 0 is my even index, 2 is my even index, 4 is my even index, and then 6 is my even index, and then 8 is my even index. So in my even index, I am assigning the value of 0 only. Okay. So I just remove this thing. Class. So I want to print this value only. I want to print this output in this sequence. Class A and then N class. So and then rand C integer at the top of A dynamic recreation, and then constraint C1, I am assigning the array size is A dot size equal to 10. I am assigning the array size. Okay. So and then in my constraint 2, I'm going to use for each loop. So for each of A of I I'm using the if else condition inside the constraint. Also you can use if else. If my A signal is model of 2 is equal to 0 means if it is 0 means I am assigning A of I equal to 0. So I am assigning the even. So it will detect the even logical elements. So even memory and indexes. So it will detect the even memory indexes from the array. Okay. So and then this is my first constraint. If indexes, and then else so I'll just remove this else if else a equal to I am assigning the value of I plus 1 divided by 2. Okay, I am assigning this. So it will, this function, if you apply this formula for this, means you can assign the, you can get the values in the odd position. I am giving the sequence values. So this is my first odd position. In the first position I am this is my first odd 1th index, I am assigning value of 1, and then in my third index I am assigning value of 2, in my 5th index I am assigning value of 3, in the 7th index in the I am assigning value of 4, in the odd indexes I am assigning the value of 1 2 3 4 5. So and then there is a logic. So and then I am creating memory for this. Initial begin, so and then creating handle. So handle means a1, so and then by using that a1 dot randomize, a1 dot randomize, so and then dollar display, I am displaying the A. Okay, display A means my array. So I just save and run. So I can't save it directly, so I want to change my file name. File name is const underscore pattern. So and then my module name is A. So my class name is also A1. So it means A2. Here I am giving A2. So both class name model name will not be same. So my model name is A. So this is my class name A2, handle name is A1. By using the handle name randomization, I am displaying the value of A. So A1 dot A. By using the handle name, I am calling the class property and I am displaying. Before going to that, I will show you the if else conditions. So this is that if, so main thing is so this bracket is for this, then this bracket no need, So this is how we can use the constraint for specific logic. So and then end is another error, end here, end module initial begin. So it will take some to get the output. I already 8.5. So I think we will continue the tomorrow session constraint. So this is examples. So there are a lot of constraints in the SystemVerilog, like if else, and then array constraint, and then unique constraint. They are simple only. So by using this kind of constraint, you can get the you can give the limitation, and then you can give your logic for randomization. The main thing is you can control the constraint by using this, but you can control the randomization by using these constraints. So you can use the function inside the constraint, and then you can use the class kind of a constraint inheritance inside the constraint logic, static constraint, bidirectional constraint. So and then constraint debugging. There are a lot of types is there. So you can just practice for yourself. So and then you have to write the code for each and every constraint. Then only you can understand the working of constraint specifically. So each and every constraints have some specific conditions, some specific syntaxes. So mostly the constraints are covered with the open and closed flower brackets only. Okay. So I think this is for today. So we can continue with the class and can continue with the constraint and also I2C protocol tomorrow. So main thing is by using this constraint you can control the randomization. Okay, I think it's clear for you. So and then we'll see tomorrow. Thank you guys, thank you for listening. So we'll see tomorrow.